Okay, we left off at this problem today. We said that if a radius is perpendicular to a chord, then it bisects the chord. And conversely, if it's a perpendicular bisector, then it is a radius, or a diameter if it goes past the halfway point. So, I ask you to think about this because you really do have all the skills you need to solve this. If we're trying to find the length of BD, we go back to our old friend Pythagorean theorem. Because if this is a perpendicular bisector, that makes that a right angle. And this line from A to D is a radius. So it's the same measure as every other radius in the circle. And so radius AE is 5, so that makes radius AD also 5. Then I can do Pythagorean theorem, a squared plus b squared equals c squared, or I can notice that it's a Pythagorean triple, so that makes that 4. And it's a bisector, so that makes that 4 as well. So the length of BD is 8. All right? Easy peasy. All right. Now, let's look at shaded regions, okay? We're going back to the 360-degree circle, and if I want to know what percent of this circle is shaded, I just take the degrees that it's covering, that's shaded, over 360. So 180 over 360 would be 50%, right? This one, 90 over 360, would be 25%, right? Didn't we do that one today? And 60 over 360 would be 16.7%, and 75%, or 75 degrees, sorry, over 360 degrees, there we go, 20.8%. Okay, now we're going to need that to calculate the area of the sector of a circle. Okay, it's the area is bounded by two radii of the circle and their intercepted arc, so that makes a sector. Okay, remember that because we're going to have some other items that we're going to need to memorize. So when we're talking about a sector, we're talking about the two radii and its arc, the area in there, the pink area here. Okay? And what we're going to do is, this should be pi, I don't know what happened here, is we're going to take the total area of the circle, which area of a circle is pi r squared. So we're going to take pi r squared, and we're going to multiply it by the percent that the angle represents of the whole thing. So just like we did right above there, it's the degrees of the angle over 360. So it's the area of the circle and then the percent that the shaded area is taking up. Okay? So let's do an example of that. All right? If we know that the radius is 16, the area of the entire circle would be pi times 16 squared. And then the percent that this pink part covers is 36 out of 360. Okay? Which I know that the degrees of the arc is the same as the degrees of the angle. So I can calculate that on my calculator. 16 squared times pi times 36 divided by 360. And I get 80.42. And if this is in meters, then it's 80.42 square meters is represented by that little piece there. Okay? Okay, so that is, again, a sector. Okay? is the part of a circle that's bounded by the chord and the arc. Okay? So it's this green part here. And if you think about it, the area of a segment is the area of the sector, which is the whole thing bounded by the radiuses, minus a triangle that I draw by drawing in the chord. So if I took this triangle part out, what would be left is the segment. Okay? So a segment is bounded by the chord and the arc, whereas sector is bounded by the radii and an arc. Okay? So let's try to calculate that. The area of the segment, since this is 12, we know these are radii, so if this is 12, this is 12. And if it's a 60-degree angle, then, so the first thing we have to do is calculate the area of the whole sector. So that's pi r squared, so pi times 12 squared times 60 over 360, which is the percent of the circle that the sector, or the sector covers. So that's 144 pi times 1/6. So I need to put my calculator up here again. So it's 144 pi times 60 divided by 360, and hit enter, and I get 75. So the entire sector is 75.4. Okay, now I'm going to subtract the triangle. Okay, and I'm going to use the theorem we learned at the very beginning, the fact that if I draw a radius perpendicular to the chord, it's an angle, it's a perpendicular bisector. So I know this is a right angle, I know this is 30, and I know that this from A to the center is half of the triangle. And I know it's a 30, 60, 90 triangle. So this is 2x, so that makes this x. Remember, because in a 30, 60, 90 triangle, it's x square root of 3, and 2x. So this side is the hypotenuse, it's 2x, that makes x 6. Okay? So the formula for the area of a triangle is 1/2 times base times height. The base then is 12, and the height is 6 square root of 3, because it's a 30, 60, 90 triangle. All right, and then I subtract that from the entire 75.4. So I find out what that is, 1/2 of 12 times 6 and square root of 3, and I get 62.35. So the area of the segment is the area of the sector minus the triangle. So that's 75.4 minus 62.35, and I get 13.05. Okay? Okay, so now you should be able to do in your packet 6 through 9 on the second page, and then 14 through 19 on the fourth page. We're going to talk about how to find the length of an arc. We're going to use this formula here, but we're going to do that on Wednesday, because we're going to spend 2 days with the computers, Monday and Tuesday. All right, so you can work on that in class. Thanks.